With the final presentation taking place for this project in December, our work on it has concluded. So I thought I would make one more video showcasing a combination of both all the previously seen features in tandem with the features newly added since the first tech demo, which will be primarily focused on the networking in the back half of the video, but there is still plenty to identify and take note of before then. So you'll first see that we've made some changes to the main menu for the program. So if we click on the controls here, we can go in and see on this UI all of the different buttons that we can take advantage of in order to manipulate entities within simulations, both during the creation and hosting process. Here are some available options that the user can adjust. These will only work once the product is actually packaged, and unfortunately Cesium is currently in a state where you can't package products with it, so the GM will currently have to run through Unreal Engine in order to both create and host any simulations. But we've made this as painless as possible by taking everything out of the editor and putting everything into the UI. So even though Unreal Engine is required, they won't actually need to have any programming knowledge to take advantage of this tool. So before anything can happen, a scenario must first be created. So we currently have 3 geographical regions that we can choose from. We have a README provided in the repo if you wish to add more of these, but there's no way to add more regions without having some coding background. So we will go ahead and go into the UCS scenario here. But first, it's worth noting what the select scenario screen looks like. We'll see here that we currently have one preloaded scenario that's going to be shown a little bit later in this video. But for now, just take note of these fields. You can set a description for the scene, and then here's how you set up the connection to whatever TAK device you're connecting to, using the end receiver for the receiver, the sender, and the multicast address for the TAK device. And then the wait time simply determines how often COT will be refreshed. So the lower the time, the more performance heavy, but the more accurate positioning will be, and things such as staling timers. So now we'll go ahead and create a basic scenario. So you'll see that we load here into UCF, and immediately if you look to the right and beneath us, you can identify the student union of our campus. So this is where we'll showcase the day and night cycle. Change the solar time at the top right. So if I change this to 19, you can see that it updates to dusk. And if I change it to 20, for example, you can see that the lighting will update shortly into more of an angled sun as it goes over the horizon. You can also adjust the increment. This will affect how long it takes to pass over time if you're not adjusting the time manually. The lower the value, the more quickly time will pass by on its own. And you can also pause time. Now I'll show off a few of the different units that the GM can use in their simulations. We won't go over all of them though. They are all described in detail in a README in the folder though in the repo. So we have a basic NPC, and here you'll see whenever a unit is dragged and dropped into the world, they're added to this custom world outliner, and any details related to that unit can then be adjusted or manipulated here using that tool. And including the ability to enable or disable their video feeds being pushed to TAK products, which will be discussed later in this video. And as well as the COT pushing to determine staling and location, since these simulations are taking place in real world areas, again also covered later in this video. For now we will just cover the NPC specific behaviors, which are the ability to set a patrol path using this crosshair, and they will continue to loop this path, which we can reset at any time whenever we want to set a new path for them. If they are to come into contact with an enemy at any point, they will engage in combat. You'll see that he shot him as he was spawned. We can showcase a missile launcher, which enables us to set a target, determine how long we would like in minutes for that missile to reach its target. Go ahead and launch the missile. We can change the camera's perspective to that of the missile's camera. Just like this, toggle back. We have a drone unit, which can be possessed by the GM, and combined with video pushing, this can be used to show TAC users out in real-world locations their surroundings whenever they request aerial support from the GM. And it has a few different features, such as filters, spotlights. Has a few different features, such as filters and a spotlight that can't be seen very well during the daytime. And of course the ability to ascend and descend. Pan around. And we can return back to the GM camera when we're ready. We have purely decorative units, such as things like this SUV, some trees and deer for the future hunting support. SUVs again, hatchbacks, sedans, a plethora of things really, bunkers, radar dishes. We tried to add a few of these towards the end. There are other units as well with behaviors that we won't go into specific details of, but they'll be covered in a preloaded scenario shortly, such as the sniper or the landmine or the rotating turret. So whenever you are finished with your scenario and you'd like to save it, you just simply press the L key, and we'll give it a name here, video demonstration. And it will now be saved and available for us to load into. So firstly, before we load back into that scenario we just saved, I'd just like to briefly load into the Grand Canyon to showcase how the GIS data can look depending on how good the satellite imagery is of that area. So for ECF, we didn't have access to very good data, but for the pre-generated ones that come with cesium, like Grand Canyon, you can see the detail is much better. But because of how the terrain is, it would be impossible to lay an accurate nav mesh for soldiers to navigate across, so you would need to be careful about doing simulations in places like this. So now we will load back into the scenario we just made in order to showcase it, that the units stay there and load back in. So you'll give it a second here as it populates everything in, and if you look at the world outliner, you'll see everything generate. And now we'll take a quick step through the pre-built scenario that I've prepared in order to showcase how some units can interact with each other when you spend the time to actually generate a scenario. So as everything populates in here, we'll pan over to the student union and take note of a squadron of 5 soldiers making their way to an extraction point. So you'll see them running in from the left-hand side, coming up first to an IED. So the frontmost 2 men will be taken down by a landmine. Then the other 3 will change their paths accordingly. And we will add in a sniper hitbox for them as an additional obstacle. So one of them is taken down in the process of aiming for this enemy on the left-hand side, but his two comrades are able to push on, and they're aiming for this VTOL, which will be their extraction point. So as they board the VTOL, we'll set a flight path for it by opening it up on the world outliner. And we're going to use this waypoint button and click it every once in a while to create a new point. And our destination is going to be this bunker on the baseball diamond. And we set the time on target, which is how long we want it to take in minutes for the VTOL to get here. So we'll do 3/4 of a minute just to showcase it working. And then we will launch it and head back towards where we placed it and intercept it during flight. And there it is, moving towards the bunker. So we'll just trace its path, showcase it landing, and that will be the end of this pre-built scenario. And then we'll move on to the networking, where Jackson from our team will show off how units can push video feeds and interact with outside TAK products, and involve real-world participants and show how their users in the game will move around as they move around in the real world. And there it is, it has landed. So this will probably be the last video related to TAKGM that will ever be posted on this channel. Like I said, there'll still be a few minutes left of Jackson showcasing all the networking related functionality, but thank you for your interest. And again, this product is open source, so I will link the repository in the description, and anybody who's interested can feel free to pull it to either use for their own needs or improve upon further. Thank you. Now I'll show off the video pushing capabilities. This is how units will send video data from the simulation for users in the real world to interact with them. You can see I have video feed 3 selected for this missile launcher, and I have video feed 1 selected for this missile launcher, as well as an NPC with video feed 2. So then if I go back to my OBS window and change the display, you can see this missile launcher is pushing video, and this NPC is pushing video, and users on a TAK device would see this on their screens as well.
We're going to take a look at how TAKGM operates with real TAK users. I have 2 TAK users set up and configured with the TAKGM operator. One is the WinTAK instance running here on the left, and the other is on another device. If you have any questions about the network configuration, please see the network configuration guide. On the right hand side here, I have TAKGM loaded in the Unreal Editor. So I'm going to go ahead and play it. So you need to make sure you have a scenario already created. I've already gone through these steps, so I'm just going to go ahead and select it. Here we can set the inbound and outbound UDP ports, as well as the multicast address for your network. And we want the COT messages to be dispatched every 5 seconds, so I'm going to set this to 5.0. And once we see this scene load, we'll see a couple of things happen over on WinTAK. We'll see a number of simulated entities appear on our map. We will also see the marker for the other TAK user appear as these 2 instances of WinTAK are now connected by the simulation. So these are all the simulated entities, and it may take another second for the other TAK user to appear. That is dependent upon the broadcast rate of the other TAK user. So we see it right here now. That's perfect. So you can see different markers represent different types of entities. All the blue ones are friendly. The red are hostile. This symbol represents a missile launcher. So I'm going to go over to TAKGM and actually launch a missile out of this missile launcher. So we have our missile launcher right here on the ground. I'm going to go ahead and set a target for it. I'm going to put it in this parking lot. This time on target is the number of minutes until the missile makes impact. So I'm going to go ahead and press launch. And you'll see right away a new marker appeared which represents the missile. And this will get updated at that rate we set in the select scenario menu. So every 5 seconds we'll get its updated position. You also may have noticed someone died down here and their marker actually staled out. That was our intended design. And as you see, the missile made impact in the parking lot, so its marker also quote-unquote staled out or turned gray, and eventually this will disappear as well. Next, I'm going to demonstrate how TAKGM updates the position of stand-in actors when the corresponding TAK user moves locations. So over here on WinTAK on the left-hand side, the location that I have this marker set at is to an arbitrary stationary location, and you can see the corresponding actor in TAKGM. So you'll notice that when I move the position of this marker, or move my position, the corresponding actor in TAKGM will be updated with the correct location.